In this session we shall see the design of highway with uniform cross-section applied from start to end of the alignment. The design is based on the alignment of the center line of the road passing through the center of the median or central verge of the dual carriageway cross-section. As the main screen opens, use File menu to select Working Folder Work located on the desktop. Next, select File menu option New and then select option New/Open Uniform Section Highway Design Project. As the project workspace opens, the current selected tab is Create Project. The project name is displayed as Design Job Number 01. Click on button Create Project. The project folder will be created in the Working Folder Work on the desktop as Work, Uniform Section Highway Design Project, Design Job Number 01. The survey data type is selected as Total Station. To select the Total Station survey data file, we click on button Browse. Select the Total Station survey data file Survey. Text from its current location on desktop, and a copy of the Total Station survey data file will be copied to the project folder. The survey data file is opened in Notepad and essentially contains 5 columns of data, which are serial number, easting, northing, elevation, and feature codes. The various feature codes are lots, P0, house, road and drain in this survey data. The project folder will be created in the Working Folder Work on the desktop as Work, Uniform Section Highway Design Project, Design Job Number 01. Next, we select the tab Process Survey Data. The current tab page is for Step 1 Ground Model. We select UTM Data Conversion, and click on button Create Ground Model. The dialog box comes for UTM data conversion. The easting and northing values of survey and GPS coordinates for the first and second points are given. Based on this values, the entire survey data will be converted from surveyor's assumed TM, transverse marcator, coordinates into GPS UTM, universal transverse marcator, coordinates. As the process is over, the list of all the survey features are displayed. We click in the color box of a feature and we select the desired color for the feature. Click on button Apply and the feature is drawn with the selected color, on right side CAD window. We remove the check mark from feature P0, as we want to deselect the feature, as shown below, to exclude it from the drawing of the ground model. Next, we click on button Draw to draw the ground model. Next, we select Page for Step 2 Triangulation, select all the survey features and click on button Create Triangulation Model to process for triangulation. As the Process dialog box comes, click on button Proceed. As the process is over, the message comes to inform about the output. Click on button OK. As the process is over, we select Page for Step 3, Contour. Next, we create the contour model by clicking on button Create Contour Model. The dialog box comes and to start the process, click on button Run. As the contour model is created, click on button Save, located at the top bar. Next, select icon for contour from bottom bar of the screen and click on button Quit to close the contour window. Next, we are back to the project workspace. Click on button Draw Contour Model. This draws the contour model and the contours are displayed in the CAD window. A zoom-in view of the contour over the ground model may be displayed. Next, we select the tab Highway Design and the current page is for Step 4, Horizontal Alignment Design for the center line of the road. We select the option New Halon Design and click on button Proceed. This opens the CAD viewer displaying the ground and contour models. Next, we select menu item Draw and Polyline. Next, we draw a polyline through the center of the contour zone. Click the right mouse button to finish the polyline. Next, select the menu items design, then, Halonment, then, New HIP method. Next, click the left and right mouse buttons on the polyline. As the design dialog box opens with model name design string label M001 start Shehnage as 0.0 meter and Shehnage interval 25 meters. Click on button Apply. If message comes for large curve, then reduce the radius and mention lengths for lead and trail transition curves. Otherwise, click on button Save and Finish to finish the design of horizontal alignment of the road center line. Turn the layers off for C001, C005 and ELEV for contours for better view of the alignment. Now to adjust the design, click on button Shift IP by sliding on one straight. The list comes for the actions in required sequence. Click on the polyline, click on the blue box at the desired HIP, horizontal intersection point, type .par in the command line at the bottom of the viewer. As shown by arrow, press enter and click on straight segment on which the HIP has to slide on. Finally, click on the straight on which the HIP has to slide on and finally fix the HIP at a desired location. Next, click on button Apply. If there is no more adjustment of the alignment is required and if there is no more error message for large curves, then, click on button Save and Finish. This will complete the design of horizontal alignment of the road center line. Next, the dialog box comes for Model Halon, by selecting the model design and string M001 and Shehnage interval as 25, click on button OK. As the process starts, the dialog box comes, click on button Proceed. As the process is over, the message comes mentioning about the report file, click on button OK to finish the process. The design report is written in file halonment.rep. We already turned off the layers C001, C005 and ELEV for contours. We display the Shehnage stations and curve details at various HIPs and view the design. The report file alignment.rep contains various details related to the design of horizontal alignment of the road center line created as string M001 under model design. At the end of the report the text data is written for 200 Halin. This data may be copied and pasted in Notepad and saved as a text file. By selecting the text file and processing by Heads Pro, the design of horizontal alignment can be reproduced. This is explained in chapter for processing of text data file in batch mode. The dialog box comes for various options for displaying Schenage along the alignment. Select string M001 and click on button OK. The Schenages will be displayed all along the alignment. Next we close the Heads viewer and we come back to the project workspace. We click on button View Halin Design and display the Schenage and details for model design and string M001 on the alignment string. The dialog box comes for various options for displaying HIP and curve details along the alignment. Select string M001 and click on button OK. The HIP and curve details will be displayed all along the alignment. Next, we select Step 5 for design of vertical profile of the road center line. Click on button Create Ground Long Section. The dialog box comes, click on button Proceed. As the process is over, the message comes informing about the ground long section is created as string E001. Under Model Design, click on button OK. The ground elevations are picked up from the triangulation file HDS001.fill by following the coordinates at each Schenage station of the horizontal alignment of string M001, under Model Design. Next, we click on button Draw Ground Long Section. As the dialog box comes with the scale, click on button OK. The ground long section is displayed in the CAD window. Click on button Grid On. The dialog box comes with the scales. Click on button OK. Next, the grid will be displayed with Schenage stations and elevations over the ground long section. Next, we select the option New V-Align Design and click on button Proceed. This opens the CAD viewer. We select Menu Item Design, then select Ground Long Section, then select Draw Vertical Profile, then select Model Name Design and string E001. As the dialog box comes, select Model Name Design and string label E001, click on OK. Next we put the grid on and the grids are displayed. We accept the default values in the dialog box to draw the grids on the vertical profile. The grids are displayed over the vertical profile of the existing ground long section. Next, we select Menu Item Draw. Next, select Polyline. Next, we select Menu Item Utility, then OSNAPS, then End, and we start drawing the polyline from the start point of the ground long section. Next, we click on a series of points sufficiently away from each other to design the desired vertical profile of the road center line, and finally click on the end point of the ground long section by selecting menu item utility, then OSNAPS, then End. We finish the polyline by clicking the right mouse button. Next, we select menu item design, then select V alignment, then select new VIP design, and we click the left and right mouse buttons on the polyline. As the design dialog box opens with model name design string label M001, start Shenage as 0.0 meters and Shenage interval 25.0 meters, all must be the same as used earlier in the design of horizontal alignment for string M001. Next, we click on button apply. If message comes for curve larget and VIP, then reduce the vertical curve length, VCL, otherwise, click on button save and finish. Next, we need to process model V-align by selecting the model name design and string label M001. The design report is written in file valignment.rep. The report file valignment.rep contains various details related to the design of vertical alignment of the road center line created as string M001 under model design earlier by design of horizontal alignment. At the end of the report, the text data is written for 300 V-align. This data may be copied and pasted in Notepad and saved as a text file. By selecting the text file and processing by Heads Pro, the design of vertical alignment can be reproduced. This is explained in chapter for processing of text data file in batch mode. Next, we select menu item design, then ground long section, then vertical details on. Next, we select model name design and string label M001 to display the design details for vertical alignment for string M001. A zoom-in view of vertical alignment for string M001 is displayed. Finally, we close the CAD viewer. Next, we are back to the previous workspace. Click on button Draw Vertical Profile. The 300 V-align data is displayed in the data window, and as the dialog box comes with scales, click on button OK. Next, click on button Vertical Details on. The dialog box comes with list of string as M001 and text size as 5. Click on button OK. The vertical details are displayed along the designed vertical profile of the string M001. The view may be zoomed in for a desired enlarged view. Next, we select Step 6, select Cross Section and select Typical Cross Section Type TCS01 for applying uniformly all along the complete length of the road. Click on button Save Schedule Data. Next, we select Step 7 to define cross-section, interface, and create cross-section. The current page is to define cross-section for creating median or central verge, main carriageway, earthen shoulder, or sidewalk, left and right service roads. By entering the various values for dimensions of relevant items, we click on button Save Data. In tab Define Cross-Section, the pages for ground elevation, left service road and right service road are not applicable for present design project. Next, we select the page interface to create data for stepped embankment slopes for left and right hand sides in cut and fill sections. To understand the data, user may refer to Help. Next, we select the page to create cross-section. We click on button Process Cross-Section Data. The process box comes with list of processes in proper sequence. We click on button Proceed to process each step with the related data as displayed in the lower part of the process box. Every time we click on button Yes to draw the strings after the processes are over, and we click the button Finish. Next, click on button Create Cross-Section Drawings. All the cross-section drawings will be created in the left side window. The right side window displays the strings created in the last process. As the process is over, we select a desired Shehnage from the list of Shehnage section to view the plan and the related cross-sections. Here user gets the facility to verify the design of horizontal alignment and vertical profile by comparing the cross-section against the alignment of the highway. We select tab Step 8 to define pavement layers on the left and right carriageways of the main road and may be in the service roads. We select each cross-section type, schedule one after another, load default data, make necessary modifications if desired, and click on button Save. Finally, we click on button Finish. Next, we click on button Process Data to create the pavement layers in the road cross-sections. Select Step 9 for estimation of quantities for earthwork and pavement layers. The default data is displayed on the screen. If desired, we can make modifications of various values. We click on button Process Data. Next, we click on button Draw Mass Haul Diagram. This is applicable where the vertical profile of the road center line passes through both cut and fill sections. Next, we select Step 10 to create project drawings for construction. The first page is for alignment schematics. We click on button Process Data and the drawings in DRG format are created for horizontal and vertical alignments in 2 successive processes, which come one after another. User has to click the button Proceed. As the process is over, the message comes, click on button OK and finally click on button Finish. This process will come twice, for processes Pro Halen and Pro V Align, and processes data as created for alignment schematics upon design of horizontal and vertical alignments as mentioned before. Next, we select Tab Page Plan to create plan drawing for various strings listed in the box. We click on button Process Data and the plan drawing is created. Next, we select Page Profile to create profile drawing, for various strings listed in the box. The start and end shenages are already displayed by taking from the previous design steps. The default length per sheet is for the full length of the road alignment. This may be changed to 1000 in case length of 1 km per sheet if desired. The horizontal scale is to be given suitably to fit the drawing to the length of the sheet. The vertical scale should be 1/10 of the horizontal scale. We click on button Process Data to create the drawings. Next, we select Page Cross Section to create cross-section drawings. The start shenage, end shenage, scale, sheet size, and other data are given in the page. We can modify the data if desired. We click on button Process Data and a set of cross-section drawings are created. Finally, we select Tab Step 11 to view various data files, design report files and design drawings now available with us. Click on button Create Update Project Data File. We can view the project data file, survey data file and design report files using relevant buttons, and view the drawings in the CAD viewer by selecting from the list and save the drawings in desired format. Below the horizontal alignment design report is displayed. User can view and close. The CAD viewer opens with a list of all construction drawings, from which user can select a drawing and the drawing is displayed. The drawings may be saved as selected type compatible to various popular CAD software. This is the end of the current session for the design of Uniform Section Highway, and we close the workspace by saving the project data file.